This meeting is being recorded.
So this video will start chapter 4, which is on chemical foundations. And so we learned that chemistry is the study of matter, and everything around us is made up of matter, and matter is composed of atoms. So what is an atom? It's the smallest particle of an element that retains the characteristics of that element. So the smallest piece that can make up the matter. So chemists use the term element in a variety of ways. So the element can sometimes refer to a single atom at the microscopic level or particulate level. Elements also refer to molecules, and there are 7 of them only that are diatomic molecules. Diatomic means that 2 atoms of the same kind are bonded together and make a molecule. And those 7 diatomic molecules are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. But chemists, when they talk about an element, they also may mean a large sample. So at the macroscopic level, you can hold it and see it. And it's, for example, a sample of carbon, just carbon. And you would see it, you can hold it in your hand. And it's only made of carbon atoms, right? So that's why it's also called an element, because it's made of only one type of atom. So elements and atoms, fortunately, combine to form millions and millions of different compounds. Otherwise, there would be no lives on Earth. So elements. All compounds are composed of 118 elements as of 2016. So that's the total number of elements that can be shown on the periodic table. You may have noticed that if you've looked at periodic tables dating from before 2016, there are new elements that have been named since then. Element 113, nihonium, symbol NH. Element 115 is called moscovium, MC. Element 117 is tennessine, TS, and 118 is oganesson, OG. So these were named in November 2016, and they are the newest ones that have been named, and that may not be included on the periodic table you're looking at if it's dating before 2016. So how many elements are there naturally occurring actually? This is a very controversial question. There is 2 lines of thought. One line of thought is thinking that there are 88 elements that are naturally occurring, and the rest of the elements are man-made. Everything past uranium, atomic number 92, is man-made. And numbers 43, 61, 85, and 87 have no stable isotopes, so they are not found naturally. So that's why the total comes up to 88 according to this line of thought. The second line of thought is that there is 98 elements that are naturally occurring and the rest are man-made. So elements 93 to 98 were first discovered in the lab in Berkeley and have now been found in uranium-rich pitch blended. So that's why they consider that it's up to 98 elements that are naturally occurring. So we'll watch now 2 songs that will introduce you to the elements. So let's start with the song of Tom Lehrer, The Elements, the original song that will introduce you to all the elements that were found and named up to that time.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Let's listen now to Meet the Elements by They Might Be Giants.
Iron is a metal, you see it every day. Oxygen eventually will make it rust away. Carbon in its ordinary form is coal. Crush it together and diamonds are born. Come on and meet the elements. May I introduce you to our friends, the elements. Like a box of paints that are mixed to make every shade. They either combine to make a chemical compound or stand alone as they are. Neon's a gas that lights up the sign for a pizza place. The coins that you pay with are copper, nickel, and zinc. Silicon and oxygen make concrete, bricks, and glass. Now add some gold and silver for some pizza place class. Come on and meet the elements. I think you should check out the ones that call me elements. Like a box of paints that are mixed to make every shade. They either combine to make a chemical compound or stand alone as they are. Team up with other elements, making compounds when they combine, or make up a simple element formed out of atoms of the one kind. Balloons are full of helium, and so is every star. Stars are mostly hydrogen, which may someday fuel your car. Hey, lead in all these elephants. Did you know that elephants are made of elements? Elephants are mostly made of 4 elements, and every living thing is mostly made of 4 elements. Plants, bugs, birds, fish, bacteria, and man are mostly carbon, hydrogen, nitrogen, and oxygen. Come on and meet the elements. You and I are complicated, but we're made of elements. Like a box of paints that are mixed to make every shade. They either combine to make a chemical compound or stand alone as they are. Team up with other elements, making compounds when they combine, or make up a simple element formed out of atoms of the one kind. Come on and meet the elements. Check out the ones that call the elements. Like a box of paints that are mixed to make every shade. They either combine to make a chemical compound or stand alone as they are.
This meeting is being recorded.
I hope you've enjoyed those songs. They said very interesting things, and so let's go through the name origins of the elements. You've heard all these names in the first song, like germanium and titanium. And so elements are named after planets, mythological figures, minerals, colors, geographic locations, famous people, etc. Let's look at some, for example. Uranium is named after the planet Uranus. Titanium is named after the Titans that are characters in the Greek mythology. Chlorine is named after Chlorus, which is the Greek way of saying greenish yellow. And that's the color of chlorine. It's a gas. Magnesium is named after magnesia, the mineral that is found in the ground. Californium, germanium, polonium, francium, americium, europium, among others, are named after states or countries. Curium is named after Marie and Pierre Curie, Pierre and Marie Curie. Einsteinium is named after Albert Einstein. Copernicium, element 112, is named after the astronomer Nicolaus Copernicus, and this name was accepted in November 2011, so a fairly recent one. So what is the abundance of the elements in the universe? Let's look at the universe first. That's the left table. So in the universe, the most abundant element in mass percent is the hydrogen. You heard in the song that hydrogen is making up stars, and helium also. So those two are, not surprisingly, then the most abundant elements in the universe, because they make up, the stars are made up of hydrogen and helium. Then there is oxygen, carbon, neon, iron. Now, if we look at the Earth, table of the right, if you look at the Earth, and this includes the crust of the Earth, the oceans, and the atmosphere around it, in mass percent, the most abundant element is oxygen, with almost 50% of oxygen are making up Earth. Silicon comes next, and when you think of silicon dioxide, which is the main element found in glass, sand, quartz, that's not too surprising. Also, there is oxygen in the atmosphere. Next comes aluminum, iron, calcium, sodium, potassium, magnesium, and then hydrogen, even though there is a lot of hydrogen in oceans because they are made up of water, in percent by mass, it's a small percentage. Then titanium, chlorine, phosphorus. And so what is the abundance of elements in our human body? The human body is made up of like 2/3 of oxygen. We are 2/3 of oxygen. Then 18% of carbon, and then hydrogen 10%. So again, oxygen and hydrogen are making up the molecules of water. So given that the cells of our bodies are full of water, then it's not surprising to see those two on top. And then all molecules have a backbone of carbon. So carbon, not surprisingly, is one of the most abundant. Then nitrogen, calcium, there's a lot of calcium in bones, phosphorus, magnesium, potassium, sulfur, sodium, chlorine, iron, zinc, and many other trace elements are found in the body. And if we look at those trace elements like iron, we have iron in our body, and that's needed for the formation of hemoglobin. Hemoglobin is the molecule that carries oxygen within the red blood cells in our blood. And without the iron, the oxygen could not bind to hemoglobin and be transported. Copper is needed for the formation of the red blood cells and collagen. Iodine is required for a good thyroid gland activity. Fluorine is necessary for solid tooth formation and retention of calcium in the bones and teeth. So you've noticed that all elements have their own symbol, right? They are unique. A symbol pertains to an element. You can either say the name or the symbol and you know which element is it. Symbols are made of just one letter, like carbon is capital C, sulfur S, nitrogen is N, iodine is I, and the symbols are always capital letters for the first letter. Then with one letter, we would not make up all those elements symbols. So we need two letters symbol for most of the elements. Like for example, cobalt is CO, and the second letter is a lowercase letter. Silicon is Si, nickel is Ni, chlorine Cl. So always have the first letter in capital and the second letter as lowercase. In older periodic tables, you may have seen three letters symbols, UUP, UUS, or UUO. But that was until 2016 when these elements have been named, right? You recognize those elements 115, 117, and 118 have been named recently, right? Like 118 is now oganesson. So let's look at a new periodic table that is up to date. And you can see little numbers above the symbol letters, right? Like for example, to the upper right corner, you see hydrogen with a capital H for symbol, and there is a little 1 above. That 1 is the atomic number, and so elements are ordered in atomic number from left to right, and then from top to bottom. And so if you look at the bottom right corner, you see oganesson here, 118. Notice how those two orange rows should be located where you see lanthanoids and actinoids within the main table. So that's why 118 is, you know, the latest element found. And so as far as what you will need to know, of course, we don't ask you to know all these elements. And whenever you will do chemistry this quarter, you will always have a periodic table before your eyes. It's a necessary tool in chemistry. But still, we ask you to learn the names and symbols for the first elements from 1 to 20 on the periodic table. So that means hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Why? Because these elements are coming up all the time, and so you will learn them even if you didn't make any effort. Seeing them so many times, you will learn them. But some elements names are not, or element symbol, I would say, are not intuitive. So you will have to make an effort to learn these in particular. So element symbol origins. Some elemental symbols come from Greek and Latin root, and that's why these are not intuitive, because their Latin name or Greek name is what gives the symbol, but then in English it's not, it's really a different root, if you will. For example, sodium is natrium in Latin, and that's why its symbol is Na. So this one you have to learn. It's not intuitive for sodium. The symbol is not coming from the name, or it comes from the Latin name, but not from the English name. Another example is iron. The Latin name is ferrum, and so the symbol is Fe. But you see, you cannot infer the symbol from the name. Potassium, Latin name Kalium, so symbol is K, capital K. Silver, Latin name is Argentium, and so the symbol is Ag. Gold, the name is Aurum in Latin, and so the symbol is Au. And then Mercury is Hydrargyrum, and so the symbol is Hg. So these are not intuitive symbols that you will need to make an effort to learn in particular, but we only ask you to learn sodium and potassium, which are among the first 20 elements of the periodic table. So we write chemical formulas for the compound because the compound is made of several elements bonded together. So to write the chemical formulas, we use the element symbols and put them together to write the formula of a compound. And so the chemical formula of a compound indicates the number and the type of atoms that are in that compound in particular. For example, H2O is the formula for the compound water, right? It's made of 1 oxygen atom and 2 hydrogens. So the subscript 2 is belonging to hydrogen. It means 2 hydrogens, not 2 oxygen, but 2 hydrogens. HCl, here you have a picture showing that it's a strong liquid, a strong acid. It's a liquid and makes a lot of fumes. Made of 1 hydrogen, 1 chlorine. NH4Br, made of 1 nitrogen, 4 hydrogens, 1 bromine. It's a powder. Calcium hydroxide here, made of 1 calcium, and then 2 hydroxide ions, which are made each of 1 oxygen and 1 hydrogen. But in total, in this formula, you have 2 oxygen atoms and 2 hydrogen atoms. And then Al2CO3, 3 times. So this compound is made of 2 aluminium atoms. And so we have 3 carbonate. And each carbonate has 1 carbon. So there is 3 carbon atoms in total. And then each carbonate has 3 oxygen, but there is 3 carbonates. So you do 3 times 3. It's 9 oxygen atoms in total in that formula.